So in section 1.3, we're going to continue solving equations. This time, we're going to have variables on both sides of the equal sign. So let's take a look at the first example here. When we have variables on both sides, we can't just combine them because they're not on the same side of the equal sign. So I can't just combine these and call it negative 13x. Instead, I have to actually move one of the variables to get it to the other side. I can move whichever one. Because the 10 is over here, I'm going to move this negative 4x to this side. To move it, I'm basically going to undo it in the way we would when we're solving. Undoing means using inverse operations. So if I'm going to undo negative 4x, I'm going to add 4x to both sides. So now I have 10 by itself equals negative 5x. From here, I can actually go ahead and solve. I can get that x by itself by dividing both sides by negative 5. I'll get x equals negative 2. At this point, I'm going to leave the check up to you guys. We've been checking our work all the time. I want you guys to continue to do that. I'm going to have you check this one on your own, okay? And I'm going to have you check all of them on your own as we move forward. So let's try the next one. Again, I have variables on both sides. When deciding which one to move, I take a look at which one has something else attached to it. Because the 3x has a plus 10 attached, that's the one I'm going to move. And I'm going to move it by doing the opposite, which is subtracting 3x. So I'll subtract 3x on both sides. I'll end up with negative 5x equals 10. That should look familiar. It looks just like the last one. We'll go ahead and divide by negative 5 on both sides and get x equals negative 2. Again, don't forget to check these. All right, on the next one, we have variables on both sides. We have a 2x here, we have a 3x here, and a 5x here. But on the left side, we have two terms that have variables. So I can actually first, before I move one, I'm going to combine those. So combining like terms is always the first step. So I'll combine those to get 8x plus 2. And then on the other side, I have 2x minus 10. Up until now, I've been moving the one that has something attached to it. But now they both have something attached. The 8x has a plus 2. The 2x has a minus 10. So I have to decide which one to move, the 2x or the 8x. Technically, there's no wrong answer. You can move either one and you're fine. I usually move the smaller one because then I won't have a negative. And if I can avoid negatives, that's always exciting. So I'm going to move the 2x. It's a positive 2x, so to move it, I'm going to subtract 2x from both sides. So I have 6x plus 2 equals negative 10. And then I'll go ahead and solve that. I'll solve that by subtracting 2 on both sides. I'll get 6x equals negative 12. And then I'll divide the 6 on both sides, and I'll get x equals negative 2. So again, we have to combine like terms, then we can move the smaller variable. We also may have to deal with grouping symbols or parentheses. So let's take a look at that in example 2. Just like before, to deal with these parentheses, we'll distribute. This time I just have to do it twice. I have to distribute on both sides. So on the left side, it'll become 9x minus 12 when I distribute that 3. Don't get hung up. Multiplying by 1/4 is the same as dividing by 4. So 32x divided by 4 is 8x. 56 divided by 4 is 14. Now I have to decide which to move, 9x or 8x. I give you a little tip to usually move the smaller one. So I'll move the 8x by subtracting 8x on both sides. Remember, it's both sides of the equal sign, so I move the 8x here and here. I stack the x's together, so I don't put it with the 12 because that doesn't have an x. So this is 1x, or just x minus 12 equals 14. Then I'll solve that by adding the 12 on both sides to get x equals 26. Let's try another one of those. Similarly, we'll distribute first, then combine the variables. So let's distribute the negative 9 on this side. Let's distribute the 4 on this side. So this will be negative 9r plus 18. This will be 4r minus 60. I want to move the smaller one. Now be careful here because this one is negative. It's actually smaller. Now it's negative 9r, so to move it, I will add 9r. Do the opposite. Because it's negative, I'll add it, which means I'll add 9r here, leaving me with 18 equals 13r minus 60. And now I can solve that. In order to get that r by itself, I will add the 60 to both sides. Add it here. Add it here. I'll get 78 equals 13r. I need to get that r by itself then by dividing by 13 on both sides to get r equals 6. So if you have parentheses, start by distributing. Always start by distributing and then go from there. Let's take a look at this next one. So the next one, we're going to solve it just like normal, but something is going to happen. So to solve this just like normal, I'll distribute the 3, and I'll get 15x plus 6 equals 15x. Because this 15x has a 6 attached to it, I will get rid of that by subtracting 15x, and it cancels. When I subtract 15x on the other side, it also cancels, and I end up with 6 equals, everything canceled, so 0. So I end up with all my variables canceling, and I get 6 equals 0. Now I have to make a decision. First I'm going to ask myself, does 6 equal 0? No, 6 equals 6. So 6 does not equal 0. So my answer when all my variables cancel and it's not true is no solution. There's no x that you can put in this problem that will work. There's no solution. Let's try the same thing on the next one. Again, I'm going to start by distributing. So I'll distribute here, and I'll end up with negative 8y minus 2 equals negative 8y minus 2. You might already notice something, but let's keep solving. I'm going to move this negative 8y by adding 8y to make it cancel. And when I add 8y to this side, it also cancels. And I'm left with negative 2 equals negative 2. This one's a little bit different than the last problem we just did, okay? We still end up with our variables canceling, and I get negative 2 equals negative 2, but this time that is true. So my answer is infinitely many solutions, which means there are an infinite number of solutions, or we'll abbreviate it as IMS. So our two special cases here are no solution and IMS. No solution happens when the variables cancel and it's not true. IMS happens when the variables cancel and it is true. If the variables don't cancel, it might just be like one of the other examples where you just have an answer, x equals whatever, or r equals whatever. Okay, so those are kind of our two special cases. Let's go ahead and try a word problem here. So in this one, we're talking about a boat. The boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. Let's underline some things here as we go. I think 4 hours is going to be important. I also think it might be important to know that it's upstream. The return trip takes 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. I want to know, how far does the boat travel upstream? So we know that they're traveling for 4 hours there, 2.8 hours on the way back. We know how long it's taking, but we don't know how far. We want to know how many miles is it going. So we're going to have to use our distance equals rate times time. We talked a little bit about this formula in section 1.1, I think. Distance equals rate times time. We're also going to make two separate expressions. We're going to make an expression for upstream, which is our way there, and downstream, which is the way back, okay? And they should equal each other because the miles that you travel upstream is the same miles that you go downstream. Even if one of them is faster, you're going the same amount of miles. So upstream, I'm traveling for 4 hours, but we don't know how many miles. So let's call x miles per hour. And if we solve for x, we can figure out how many miles per hour. If we find x, we can figure out how many miles. So x is miles per hour. So upstream, we're going for 4 hours at x miles per hour. Downstream, we're going for 2.8 hours, but we're not going x miles per hour. We're going 3 miles faster. So we're going x plus 3. So now I'm going to solve this for x, which is my miles per hour, my speed, And then I can use that to actually figure out how far my boat's going. So I'll start by distributing, just like always. So 4x equals 2.8x plus 8.4. Let's move the 2.8x because it's attached to the 8.4. So I'll subtract that on both sides. And I'll get 1.2x equals 8.4, and then I'll divide by 1.2. When you do that division, you end up with 7. So I'm traveling 7 miles per hour upstream, but I want to know how far I'm going. So if I'm going 7 miles per hour for 4 hours, off to the side here, I'm traveling for 4 hours times 7 miles per hour, which means I'm going a total of 4 times 7 is 28 miles. So that's it for for 1.3. So make sure you go back and check this out. Again, we're solving here equations that have variables on both sides.